All right, so just like we've been doing all week here, this is going to be our last in-person review session. I've got last year's final, and we'll go ahead and do it. Otherwise, the last review that I'll do is the Advent of Code Day 4 tomorrow, and of course that's on YouTube. The last 3 days are all available on YouTube as well, including the one from Monday that we did in class. The final exam is Tuesday, December 17th, 3:30 to 5:30. It's right here in Henslick 124. As with the midterm, it's open book, open note, and required computer because you'll be doing live coding exercises. You'll submit them through the web hand-in and the web grader, and you can resubmit them as many times as you want within that 2-hour period. And so it's very, very similar to the midterm. There are 4 exercises that have been designed, each worth 50 points. We grade them with the same rubrics as the assignments, so style, documentation, design, and correctness are all important. It's graded only out of 150 points, though. So you could get up to 50 bonus points, up to 5% of your grade bonus on the final exam. Any additional points beyond that 150 is going to be bonus. So if you're not shooting for the bonus, then of course you'd only have to do 3 out of those 4 exercises. You'll have 2 full hours, so if you plan ahead and think you want to do all 4, like a half hour each would be a good plan of attack. More bonuses, well, with the course evaluation, 82 responses so far, just like the midterm evaluation. We'll give you up to 5 points bonus on the final exam, depending on how many, what the response rate is. So currently that response rate is 82 out of, I'm estimating 132 will sit for the final exam. So we're about 60% already. That's 3 bonus points that everybody gets on the final exam. If we get up to 100% there, then everybody will get those 5 bonus points. Okay? All right, any questions on the final exam? Mark your dates because every year there's at least one person, I forgot I slept in or something like that. Don't be that one person. Right? Here is the final from 2018. Right? And hopefully you remember what we did on the midterm for 2018. It's FizzBuzz again. And yes, that was not a mistake. I remember during the final several people looked up and said, are you sure that this is right? Yeah, it's right. It's free give me points for those people that actually got it. And I was actually interested to see, is there going to be any difference from the midterm to the final? And disappointingly, there was not. People who could not do it at the midterm still could not do it by the end of the course. So let's go ahead and remind ourselves that we can do it. I don't have a file here. It was from scratch, fizzbuzz.c. And let's remind ourselves of what this looks like. Write a full C program from scratch that solves the classic FizzBuzz problem. You output integers 1 to 100, 1 to a line. However, if the integer is divisible by 3, you output fizz. If it's divisible by 5, you output buzz. And if it's divisible by 3 and 5, and the common solution is that if it's divisible by 15, then you should output FizzBuzz instead. Okay? So it is from scratch. Let's go ahead and make sure that we get all of our documentation and style points by putting in a header file here. What is today? The 11th, right? And a short description. This is yet another FizzBuzz program. All right? There we go. That's good enough for this. Let's include our libraries. So include the standard library. Let's include the standard input-output library. Here's our main. And I'll go ahead and make sure that everything is there. Int argc char argv return 0. Right? So one tip that I would give you is come prepared with stuff that you've already written. Right? You've written now. Everything was designed in this course to build on other stuff. For example, get file lines. Right? Hopefully you found like 2 or 3 uses of that function. Maybe you can come prepared with get file lines. Oh, that'd be great. I'm going to use that. Cut, paste, done. And now it cuts down on the time that you actually have to program. And of course, if it's bug free, then you know that it's going to work. come prepared with a shell program like this to get started, right? A basic hello world program that you can immediately get started without having to write the boilerplate kind of stuff. Question? No? Okay. All right. So it's just FizzBuzz for int I, starting at, I think we need to start at 100, right? Or not 100, 1 to 100, sorry. We'll start at 1, not the usual idiomatic 0 up to n minus 1, whatever. I less than or equal to 100, inclusive on both ends, I plus plus. And just like before, we need to look, it's an if-else-if kind of condition, so we need to look at the most specific one first, the most specific case. And so that's going to be if I is divisible by 15. The remainder, when you divide it by 15, is 0, so it's divisible by 15. We'll print out FizzBuzz and the line. Right? And I don't think that we took off for people who misspelled it, but come on, come on. Right? I mod 3, I think it was, is equal to 0. Right? And it was print fizz instead. Else if I mod 5 is 0, then we will print out buzz. There we go. Else, the last case here is where you actually print out the number I. Right? And the placeholder for that is going to be control D, or %D. Right? Let me go ahead and compile this, make sure it runs. I think that this is in desktop final. There we go. GCC FizzBuzz, run it. All right, looks good to me. Right, but of course, if I had done this on the midterm, I'd already have it ready to go, copy, paste, update, maybe fix it up, whatever. And of course, I would never do the same thing again, right? All right. All right. So the second part of this is there were only 2 exercises this year. I forget what we graded out of, but it was 150, so there's no bonus available for this. Or maybe there was. No, there was no bonus on this one. So Pokemon is a game in which fictional animals are forced to fight each other by their cruel masters for sport. Each Pokemon has a type of attack, a defense. For example, there are ice Pokemons, grass, fire. I've never played it before, ever. I've just assigned this as an assignment before, and then I assigned it as a final last year. When an attack of type A is made against a defense of type B, the result may be have a force multiplier. So 0% is not effective at all, 50% half effective, 100% or 200% are super effective, right? And an example table can be found here. Okay, it's still live. Right, there. It looks like this. So apparently there's a normal Pokemon, okay? There's a fire Pokemon, water Pokemon. So that if water attacks fire, then you can see a 2 here because of course water puts out fire. I don't know, is there a wood or steel? I don't know what. I don't know any of these. So. Ice. Okay, so if ice attacks fire, it shouldn't be effective at all, right? Okay, it's only half of effective, apparently. All right, so this is basically a matrix here of effectiveness. So what we did is we took all that data and put it into a bunch of files, 2 files, a list of Pokemons and their type, and then we flattened out that matrix so that if an ice attacks a fire, then it's only half as effective, okay? So we provided 2 files. The first one is a CSV file containing data on 151 Pokemon named Pokemon.csv, and we provided that. Let me go ahead and just get rid of this. Where is it? Pokemon.csv. So 001 Bulbasaur grass, 002 Ivysaur grass, et cetera, et cetera. So these are in order. This is just data that I grabbed off the internet or whatever. And they're all CSV data, okay? So and the second file that we're given is a Pokemon types.dat, which contains, again, this kind of stuff. And that's over here in no particular order. In fact, we randomized it. That if rock attacks poison, then we've got 1.0. So the way that you would go about determining what's going to happen is we would give you a Pokemon name, say Bulbasaur, which is grass, and Charmander, fire. So suppose that Bulbasaur attacks Charmander. You'd have to look up to see what happens. Here's Bulbasaur. He's going to be grass. Here's Charmander. He's fire. So we need to look those two things up. Then we open up this other file and find out what happens when a grass attacks a fire. Grass, fire. Right? And we'd be searching around for that one right there. It's half as effective. That's the number that we ultimately report. Okay? So we've got file processing. Maybe we even want to design a structure to represent a Pokemon. We could do this many different ways. We provided some starter code along with some utilities to help you along the way. At least we did last year. We may or may not do the same thing this year. So let's take a look at the utilities here. Oh, there's a nice deep copy string function for us already. Okay. There is a split function. This is a utility function that splits a string into an array of strings along the provided single character delimiter. The last parameter is used to inform the calling function of how many tokens it found and thus the size of the returned string array. So we don't have to do that. That's going to be convenient. Chomp removes any trailing white space characters from the end of the given string. And finally, free a string array. So presumably if we get a string array from split and we want to make sure to clean up after ourselves, this does it for us. Those are all already provided to you. What we need to do is we need to decide what we want to implement and put any helper functions down here to help us with that. Okay? All right, so suggestions on how to get started. Again, from command line arguments here, we're going to take the Pokemon name 1 that attacks Pokemon name 2. We're going to have to look up their types, and then we're going to have to look up the type combination over here. All right? So, any ideas on how to get started? Yeah. Okay. Let's go ahead and make a structure for Pokemon. Right. Type def. Struct. And what should we call it? Pokemon. All right. All right. What is a Pokemon according to this over here? I didn't put these numbers here. Apparently, those are the Pokédex ID or something like that. So we could go ahead and take that if we wanted to. But then we've got the name and the type, which are both. We'll just go ahead and make them both strings. You could go and waste your time making an enumerated type here of each one of these things, but that's a lot of typing. Right? I'm just going to go ahead and keep it simple and make a Pokemon that has a name, char star name, and a type. And since we're not going to be using that identifier, we don't have to worry about that. If you really wanted to do it, of course, maybe int ID or Pokédex ID. I don't know, whatever you want. I'm going to leave that off for now. Okay. What else might be useful? Now that I've got a structure to represent a Pokemon, okay, let's have a create Pokemon function, right? So maybe I don't know, or maybe an init or a create. Let's go ahead and go with init. So void init Pokemon, right? Where we're given a const char star name and a const char star type, right? And it's going to let's do some deep copies of this. Oh, and of course, if it's an init, we're going to have to give them a pre-existing Pokemon that's already been created for you. Pokemon, and I'll just call it P. Right? So help me out. I want to copy that name into the Pokemon P's name. P dot name is equal to, or what? This is a pointer to a structure. So do I use the dot operator or do I use the arrow operator? Arrow operator. All right, so let's go ahead and create enough memory for it. Char star Malik. Stop me anytime if you have a better idea here. strlen of name. Nobody has a better idea? Oh, and then I forgot +1. What did we give you? Deep copy. Deep copy of the name. There we go. P's type. Oops, type is equal to a deep copy of the type. There we go. And now we have a creation function. If you wanted to do create Pokemon instead, it would be a little bit different, right? Whichever way you want to go. You don't need to do both, of course, unless you really want to, right? All right, so let's go ahead and go and create an array of all these Pokemon based on this CSV file right here. Right? How many of them are there? I don't know. Does anybody know how many Pokemon there are off the top of their head? Well, technically, yeah. What is it? 151, right? So we could hard code that, or we could walk through and just do a while loop and until we get to the end of the file or something like that. But we know how many Pokemon there are, and it's not going to change. So let's go ahead and just say that there are 151, right? Okay. Let's go ahead and create an array to hold them all. So a Pokemon array, all right? Pokemons, is that the plural of what is Pokemon or Pokemon? I don't know. What is it? I'm asking genuinely. I don't know. Pokemon. I think it's probably just Pokemon, isn't it? Okay. That sounds better, at least. As good as it can sound, I suppose. All right. So Malik, n times how many bytes does a Pokemon take? Size of Pokemon. There we go. This gives me a regular old array of Pokemon. If I go and look at Pokemon of 0, that's a regular old structure, one which I would use the dot operator if I were going to access stuff. A lot of people have chosen to do an array of pointers to structures, which is perfectly fine. You just need to reread the chapters to make sure that you're doing it consistently and you know what you're doing. Okay? I'm going to go ahead and go with the simple solution here. Right? Now I want to open up that file, process it line by line, and pass in, and then initialize each one of these Pokemon. Right? So I'll go ahead and open up the file, and fopen, and the file was Pokemon.csv, and I want to open it up for the purposes of reading. Okay. Now, since I know up front how many there are going to be, I can go ahead and there's no like beginning line that says that there are 150 there, right? The first line was the first Pokemon. So I'm just going. All I'm going to do is go up to n, or -1, of course, plus, and I'm going to read the line, read the next line. To do that, I'm going to create a buffer. None of this was super long, so I think 100. A buffer size of 100 would be more than enough. Right? And how do I read one line from a file? Does anybody remember, or did everybody forget? Right? Forgets. Right? Into the buffer, at most 100 -1, because the null terminating character is taken care of for you from the file f. Right? Now, this line is in the buffer. Remind me, what about that end-line character? Does forgets get rid of that for you? Nope. All right, so I'm going to have to do that for myself. Or, there, chomp. Right, nice. All right, let's go back over here. Chomp the buffer to get rid of any trailing white space. In fact, if I had like a bunch of spaces here, it would still be immune to that because the chomp would take all those out. Okay? All right, I chomped that out. Now what do you want to do? Now I've got basically what amounts to this thing right here. Let me bring this over so that we remember what it looks like. Right, just temporarily, this is not good. This is not actual code here. So it's CSV, so should I start using strtoc? Or wait a second, what else was given to me? Oh, oops. I need to move this over to the, is this where a function belongs, by the way? What file am I in? I'm in utils.h. Prototype should go there. Right? And in fact, come back, full points. I need full points. This function initializes the given Pokemon using deep copies. That's good enough. And let's make sure that it's over here. There we go. So do I need to use strtoke myself? Or can I split a string along some delimiter and it'll tell me how many tokens I got? Right? So let's reuse that. Right? So what I'm going to, I'll call it tokens. I'll call the split function here. The split function was you give it the string that you want to split. You give it the token that you want to split it by. And remember that it is, where is split? It is a single character delimiter. I chose not to implement it like strtoke where you can put in multiple delimiters. I just wanted to keep it simple. And then the last one is going to be, it's going to tell you the number of tokens. Right? So let me go ahead and create that variable here, num tokens. Right? And that's going to, because it can't return two values, it can only return a pointer to the actual array of strings, we have to pass this by reference. Okay? Am I doing it right? So over here, this last one is being passed by reference. It expects an integer pointer. Is this an integer pointer? This is a regular old integer. How do I pass it its pointer? Ampersand. There we go. Let's do some basic error checking. If num tokens is not equal to 3, then printf error file corruption, or something like that. I don't know. Otherwise, we're assured, and we'll go ahead and exit. Maybe that is an exit condition right there. Right? You've corrupted the file. There's some line that has 4 tokens or 2 tokens. We're missing the Pokemon's type or something like that. All right. Now I need to use those tokens. I want to initialize the ith Pokemon here. So init, down here, int I, there we go. Init Pokemon. Remember that we need to pass it the ith Pokemon, so Pokemon of I. And the name, well, remember what the tokens were? And I erased it. The name is the second token. The type is the third token. So what would I pass in tokens of 0 and tokens of 1? Is that the second token? And that's the third token? Nope. 1 and 2. That first token was the number, right? Remember over here, this number right here. Right? Is that correct? There's something still wrong with this. Init Pokemon, what does it take? We designed it to take a Pokemon pointer. Is the ith Pokemon over here? I'm getting tired of saying Pokemon. So anyway, is the ith Pokemon over here, is that a pointer to a Pokemon? Nope, it's a regular old variable. So how do I change a regular old variable into a pointer? Ampersand again. Right? Now, if you want to be absolutely sure, you can go ahead and print out all your Pokemon, and you can, and we can do that really quick here. Make sure that it actually worked. And instead of making a 2-string function, I'm going to get rid of this anyway. Printf red Pokemon %s, and then of type %s, and the line Pokemon of I. Now, dot or arrow to get the name. Is it going to be dot name or is it going to be arrow name? Pokemon of I is a regular old structure, so I use the dot operator and Pokemon of I dot type. There we go. Let's make sure that this works. Oops, I did not have, tokens. There we go. Tokens. There we go, just misspelled it. All right, what am I doing? I need to not only do Pokemon.c, but utils.c. I can do it all in one shot here, or I can do it in a couple of iterations here. Let's go ahead and run it. Okay. I have to provide A and B. I'm not to that point yet. Oh, darn it. Didn't actually print anything.
Your I is not initialized.
Oh, thank you. There we go. So that's an interesting question. What, again, it goes back to an uninitialized variable has what value? Now, if you said the default of 0, then yeah, okay, you don't need to do that. But apparently you do need to do that, right? Especially in this case. There we go. I don't know, does anybody, I'm just going to look at the last one. Mu of type psychic, is that the last one? Mu of type psychic, and so I'm going to assume that they're all correct if I got the last one correct. And the first one was Bulbasaur of type grass, correct? You tell me. All right, so that looks good. I could go ahead and get rid of this. If I turned this in, though, that would be dead code. Bad style. Don't do that. Right? Don't get rid of all your debugging code. Okay? It wasn't actually really debugging code anyway because it's not a real debugger. It was just sanity. It was just a sanity check to make sure that I've got everything. Okay? Now there's one more step before we go on here that's going to lose me some points on design. Does anybody see what it is? Yeah. Oh, what do you mean? Oh, the white spacing? I think the white spacing's all right. Like you'd want to double space everything? Okay, or maybe major parts like this or this or something like that. That's not that big of a deal. But from a design standpoint, what happens to each one of these token arrays, these arrays of tokens, after I'm done? I don't know if I have Valgrind installed here. Which Valgrind? Nope, I don't have Valgrind installed here. But what would Valgrind tell me? That there's a memory leak. Where? This tokens needs to be cleaned up. Right? Strong hint that we gave, free string array. Right? We gave you a free function to do this. Do it. Use it. So free those tokens after you're done. Okay? That's good. All right, so I've read in all my Pokemon. Now, what I've got is this first Pokemon and this second Pokemon. Let's go ahead and put those into variables. I could have, of course, just use argv sub 1 and argv sub 2, but I like more descriptive variable names. So let's go ahead and have a char star Pokemon A, or attack is equal to this. Attack name, or just A, I don't know. A attacks B, char Pokemon B, and that's the second argv, or the second actual command line argument. And again, what we're going to want to do eventually is output this. So if you call it with Jinx Flareon, Jinx is of type ice. It attacks Flareon of type fire, and does this number will have to be looked up in the other file. Okay. So if I've got these, what's my first step? I need to find out what types of Pokemon this is, right? So how would I go about doing that? I would iterate through this array here and find the Pokemon with that name, right? So let's iterate through each one of the array here, and I need to find that first Pokemon. So if Pokemon sub I, if its name is equal to this name right here, right? How do I do string comparisons? Oh, strcmp. Pokemon 1 I's name, and I use the dot operator here again because it is a regular old structure. I compare it to this first Pokemon's name, and if they're equal, what should this return? 0. And I've found what I'm looking for. You found the first Pokemon. Okay? Let's store that off as an actual Pokemon. A. First Pokemon? I don't know. Just A for now, right? And B, right? There we go. In fact, let's. Do we want pointers to them or not? We might want to come back and make them pointers instead. Okay. So found the first Pokemon. So let's go ahead and say that A is equal to Pokemon sub I. Right. Now there is a little bit of a mem copy going on behind the scenes that's opaque to us. We don't have to worry about that. There's no these are both statically declared on the stack, so there's no memory leaks here at all. Or what you could have done is you could have saved off the index, right? So let's do that instead, actually. So int index of A and index of B. Right? What should I initialize these to? 0? Okay. What's one potential drawback to that? What if I do, I don't know. What if I search for a Pokemon named Ryan Reynolds? Is that going to show up? No. So, but if I initialize it to 0, then that kind of says that, and I never reset it because I never find Ryan Reynolds, then what's going to happen? It's going to assume that Ryan Reynolds is the first Pokemon, whoever that was, Bulbasaur or whatever. Right? So, what is a value that I can definitely know that that's not a valid Pokemon? -1. That'll never be a valid value. Right? So, I found the first Pokemon. Index of A is going to be equal to I. Do the same thing here. Now, should this be an else if? It could be, because assuming that these Pokemon are going to be different every single time. But I don't know, is it possible that a Bulbasaur attacks a Bulbasaur? Oh, okay. So then we don't want an else condition, right? I would not have known that. Thank you. All right. And we want to compare it to B instead. Okay? All right. So they attack their own kind, huh? Okay. I guess if they're ordered to. All right. Let's move this one down so that everything's together. Now, assuming that I've found what I'm looking for, then I can go ahead and proceed to look up the types with the other file. But let's do some basic error checking here. If index of A is still -1, or if index of B is still -1, then I did not find the Pokemon I was looking for. Printf, error, cannot find such Pokemon, end the line, and you're done. And then there's no way to recover from that because you gave me Ryan Reynolds and it doesn't exist. Okay. In fact, let's go ahead and print out. Otherwise, if it's success, let's go ahead and print out what we found so far. I'm just going to cut and paste this one. Its name, its type, and then the damage that it does. So replace that with a string. Replace that with a string, 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 and then this will be a floating point number. And what I pass in is going to be Pokemon of index of A, its name, then its type, and then all over again with B. Oops. B, B, and then some value. I'll just put in 0 for now. Okay? All right. Oops. Okay, fine. Really persnickety. It's going to be a double, so it's got to be 0.0 instead. Too few. Oh, free tokens. Darn it. Up here, I have to tell it how many tokens there are, so num tokens. Right, there we go. Thank you, compiler. Run this again. Okay, error because I didn't give it any Pokemon. Bulbasaur. Is that correct? Sar. And give me another one. All right, I'm just going to have to cut and paste a random one. There we go. Bulbasaur and Charizard. Grass and fire does 0 damage. Of course, now that's the number that we need to look up. So I'm pretty convinced here. Let me go ahead and add in an end-line character. I'm pretty convinced that this works because if I give it something else like Ryan Reynolds, right, then cannot find such Pokemon. Right. There we go. All right. So now all we have to do is take care of this number right here. I've got the type of both of these Pokemon. So I want to go through and find the multiplier. Okay? So let's go ahead and process that file. I'll go ahead and go with File. Now, I could go F here, but it was already opened up here. In fact, that reminds me, once I'm done with that file, what should I have done? If I close the file. So I'm just going to reuse that file pointer here, but I'm going to be opening up a different file. Fopen, and what was it called? Pokemon types.dat. And I'm going to also open it up for reading. Now I want to go through, like this example right here where it was grass and fire. I want to find that one line that has grass, fire. Right? And then I want to get this number right here. Okay? So let's go ahead and process it line by line. Once I've got one line, once I've got this line, what should I do? I've got 3 tokens here again, right? But there's no comma, so it's not CSV data. Instead, but I could use the same thing that I used before. I could use this split function right here. Right? So let's go ahead and go into a loop here. What kind of a loop do you want now? Well, you could go into the file and find, oh, well, there are, I don't know how many types there are, but whatever it is squared is the 324 324 possibilities. So you could, cheat a little and say, well, I know that there are only 324, so I can go into a regular old for loop. Just for variety here, let's go ahead and go into a while loop. Okay? Remember, forgets operates by reading into a buffer at most 100 minus 1 characters from the file f, but it also returns a string. That string, a string pointer, a char pointer, or a char star. Only when it gets to the end of the file does it return null. So you can use that here, and while s is not equal to null, then you need to read the next line. Okay? But since we've already read the first line up here, we're going to process the current line, and then read in the next line. Right? Well, that's easy enough to read in the next line. That's just a cut and paste right there. Process the current line, though. How do I do that? The current line is in this buffer. I want to split it out. Char star tokens, use the exact same one that we did up above. Split the buffer, but now it's not a comma anymore. It is a space. And then num tokens, just like before, ampersand, and of course I will need to create that int num tokens. Okay? There. So this is going to return a line that has been broken up. It's going to be fighting, and then electric, and then this last token right here for me. Right? If I did it right, I think I did it right. Nobody complained last year. But now I need to, now I can look those up, right? So I can make a check here that if I've got this type, type A, right? If one big condition here, if the string representing Pokemon, the first Pokemon's type, is equal to the first token, in other words, strcmp returns 0, and the second Pokemon type is equal to the second token, then I found my needle in the haystack. Right? So found the combination. So again, if the type of the first Pokemon, that's a string, fire, is equal to this token, fire, and the second type's is equal to the second token, this one is attacking this one, and so we found the combination that we're looking for. And so I need to save that off. Double multiplier. Right, equals, I'll set it equal to negative 0.1 to see if we can actually, maybe we're not going to be successful. Maybe we don't find it. So a multiplier of negative 1 is kind of like an error flag that we can then use. But otherwise, multiplier is going to be equal to, now how do I get that third token? Oops, not this one anymore. We're done with that. How do I get that third token right there? Token sub 2. Is that going to work? The thing on the left-hand side is a double. The thing on the right-hand side is a char star. So are they compatible? No. How do I change a string into a floating point number? A to I? F, floating point number. There we go. All right. and then I can print it down here. Let's just make sure that this works. We'll come back and maybe change some things. Oops, tokens, all good, tokens, there we go. All right, okay, the same error code as before, so Bulbasaur and Charizard, is that right? 0.5. Grass attacks fire is at 0.5. Grass, fire. Okay, that works. Give me another. I've already closed the file. Give me another combination. Nobody wants to admit to playing this game. It's not ice and fire. I have to actually have Pokemon names here. Charmander. Is that right? All right, and then Squirtle. Oh, wow, okay, I got it. And is that right? Fire attacks water. Okay, because it's half as much. I assume that if you go backwards, that it should be twice as much, because if you are, water puts out fire, right? Okay, all right. And what about Ryan Reynolds? All right, can't find such Pokemon. So, what? Garantina? What? I have no idea what that is. Okay. Foo. All right, can't find such Pokemon. All right. So that looks pretty good. If we wanted to do a little bit more error checking, we could have said, well, what happens if this process right here fails, right? And of course, I need to close that file. What happens if this process fails? We can do some more checks here. If the multiplier is still, or is less than zero, right? Then we can go ahead and say printf error cannot find type combination. Right? There we go. And then exit, maybe. And that's not going to show up because, of course, I've got all the correct data here. But we can test this if I put in, let's see, if we take out this type, grass and fire. If I took that out, then it would no longer be able to find that that Bulbasaur Charizard. What? Yeah. Okay. There we go. Cannot find type combination. Right. So there. Let me restore that so I don't screw up my data over here. There we go. Yeah. So just some basic error checking. If you couldn't find that combination, then you could echo an error message instead of printing out some random garbage. Or this one attacks this one with a multiplier of -1. Right? That's what would have happened anyway. All right. All right. I think that this is good. I don't have any grader set up, but of course we could put this in, and there would be 5, 10 test cases, and you'd have to look at them, input, output, etc. I assume that most people, or a lot of people, have played it before, so you could also make your own test cases. I know that one. I know that one. I know what the multiplier should be. Right? All right. Any questions? That was the entire final right there. We did it in 45 minutes. If I weren't talking, I would have been able to do this in 20 minutes. So I always put a multiplier on. I always do the assignments because we need an answer key. And so I take the time that it took me to do it, and I expand that out by a factor of 3 or 4 or 5 or something. And so 2 hours definitely doable on this. Okay. And that was the last one. So to reiterate, Tuesday, December 17th, so 6 days from now, I believe, 3:30 to 5:30. It's in right here in Henslick 124. I believe all of the chairs have a power bar at the bottom, so make sure that you are bringing your power cords. It's open book, open note, of course. You can use any code that you produced as a part of a hack, a lab, or anything that you can bring with you. Required computer, of course, because you will be doing live coding exercises. Closed communication, you are not allowed to talk to anybody or use any instant messenger apps to talk during the exam. Live programming exercises, you'll use the web grader. I didn't use the web grader here, but it will be set up for the final exam. There are four exercises, each worth 50 points, graded just like assignments with style, documentation, design, and correctness, with correctness, of course, being heavily weighted. It's graded out of 150, which represents about 15% of your final grade. Any additional points beyond 150 will get you bonus. And if you fill out the course evaluation, then the completion rate on that will be factored into your final up to 5 points, just like the midterm. So far, 82 people have done it without me saying anything, so good job. All right. Any last questions? Otherwise, I'll see you on Tuesday and maybe next semester. All right. Good luck in all your finals.